Okay. So now we will describe to you how we do this experiment. Okay. Now as you can see on your screen, we have turned on the power supply to the electromagnet, and let's say we have done the part where we have performed the calibration of the electromagnet. Okay. So we know for what current we expect what magnetic field in the pole pieces. Now we have also placed the tube with the solution in between the two pole pieces. So there are a few things that you have to be careful about. The solution, you have to fill it without any bubbles in it. Okay. If there is a bubble, you have to shake it a little bit so that the bubble is gone. Otherwise, the bubble will interfere with the experiment. Okay. I will describe to you why it will interfere. But for the moment, first thing you have to remove the bubbles in it, and then you have to make sure that your meniscus of that liquid solution, it should be more or less in the central region. Okay. Now the thing is, this pole pieces, the electromagnet is producing the magnetic field that it is producing between these two pole pieces. It's not exactly uniform, okay, but near the center of its pole pieces, it's more or less uniform, and that is what the value that you know for. Right? So you have to make sure that the meniscus is close to the central part or the middle region. Alright. Next, you have to use this microscope telescope here. So you have to change the basically the position of the two lenses in the telescope so that you are able to focus and see the meniscus clearly. Now this is a water-based solution, so the meniscus will actually be sort of a concave meniscus. Okay. But inside the telescope, you will see it convex. Okay. That is because the telescope and this lens arrangement is producing an inverted image. So first you will start with a zero magnetic field, and then you will note down, focus the telescope to that meniscus, and you note down what is the reading from here. So that is the reading without any magnetic. Once you give some magnetic field, provided your magnetic field is strong enough, you will actually observe that the meniscus of this liquid is going up. Okay. So up in reality is going up, but inside the telescope you will see that it is going down. But anyway, so you have to move the telescope up to bring it to bring the meniscus again to the crosshair of your eyepiece. Okay. So this is roughly the experiment, because now what you will do, you will set different magnetic fields and measure the heights. Take the difference again from the height for zero magnetic field, that will give you the height by which the liquid has risen for that particular magnetic field. Now how will you produce different magnetic fields? So you have this power supply. So you see there are two different knobs there controlling the voltage and the current. So usually they are coupled. So what you can do is set the voltage to a maximum possible value and then change the current. Okay. You can change in steps of 0.5 amperes or more if you want. The maximum value is around 2.7, 2.3. That's the maximum allowable. Okay. Otherwise, this solenoid will get heated. So the heating of the solenoid will also affect your experimental results. So you keep changing the currents, that will produce different magnetic fields, and the solution will rise to different heights. Okay. So you will collect a data basically for height versus applied magnetic field. Eventually, if you look at the expressions are in the manual, so I will not describe them in details. So if you look at those expressions, you will see that the susceptibility is dependent on p square. So you will plot a line, you plot your data and then fit a best fit straight line to h versus b square. From the slope, you can estimate the susceptibility of the solution. So that's basically the calculation that you need to do from the data directly. After you have done this susceptibility calculation, there are a bunch of other calculations which I will describe in a moment, but details you will find in the manual. Now, what is happening is now this solution is in between the pole pieces of the magnet. What happens is basically you have the dipole moments aligned now along the direction of the magnetic field, but this magnetic field is sort of more or less. So when we start the experiment, actually we need to keep the meniscus a little bit below the central part. So as you apply magnetic field, the meniscus will try to move to the region where the magnetic field is maximum. So that is basically close to the central part. Okay. So that is why you will observe a rise in the height. Now, what are the different forces that are acting on this solution? So one is basically your magnetic force. Another one is basically the buoyant force of the fluid, because the air has a buoyant force. The fluid, if it has to go up, it has to displace the fluid. That is the air there. Then there is a weight difference. So all these factors together you have to take into account. In the manual you will see all these different factors are You have to take the net force, and that will be equal to your magnetic field force. Okay. Next, you will take out this tube and you will fill the new solution to it, and you will repeat the same experiment with a different concentration. So you will get a susceptibility with different concentration of the data. From there, you will calculate what susceptibility that you will get directly from here is basically susceptibility per unit volume of the solution. From there, you have to find out the susceptibility per unit mole of the active substance. Okay, that is the manganese sulfate. Because water does not contribute to the susceptibility, because water is a diamagnetic substance. There is actually a small correction from water as well, but we will not go into the detail. So water is not paramagnetic, so it has no contribution to it. From the susceptibility of the per unit mole of the solution, then you will see that there is something called Curie's law, which also predicts what the susceptibility should be for a paramagnetic substance. So you will use the Curie's law and calculate the expected value of the susceptibility from the given data that is available to you, that is the concentration of the solution, molarity of the solution, molecular weight of the substance. All this data is given to you in the manual. Then you will calculate. Then you will cross check if it's matching, if the prediction of Curie's law is matching by data you are getting. Okay. So that is the experiment. Thank you for listening.